Hello, everyone. Today's webinar is about our 5G products, Baicells 5G products. I'm going to cover some 5G basics at the beginning, some basics and principles, and then I'll take you through some of our 5G products. Baicells, we are a global company. We do exist in over 55 countries. We have over 40 global partners, and we've shipped over 200,000 devices in 100,000 small cells and counting. So what is 5G? 5G is the fifth generation of wireless systems based on 3GPP release 15 specifications. Every 10 years, we do have a new wireless generation. So 10 years ago, we started the LTE, 20 years ago, 3G, and probably 10 years from now, we'll have 6G. But let's focus on 5G for now. There are three basic concepts when it comes to 5G. Enhanced mobile broadband, which is, we refer to it as EMBB, and ultra reliable and low latency communication, referred to as URLLC, and then massive machine type communication, MMTC. Let's look at this triangle here, where I have what I just listed indicator on here. So enhanced mobile broadband, this is about speed. 5G will reach speeds that are over 100 times faster than LTE and 10 times faster than LTE Advanced. So we will be reaching like 10 gigabits per second. So no more megabits per second in this technology. It's all in gigabits per second. Some of the applications that use enhanced mobile broadband, for instance, if you want to download an HD movie, it'll take you 1 second. If you want to watch 8K streaming, you will watch it without any delays, without any jitters, just as real time as it can be. And as we go down this side of the triangle, you'll see some applications as well when it comes to work and play in the cloud. Some of the games that your kids probably playing requires lots of bandwidth to avoid any delays and lags. So that'll be more clear in 5G technology. As we go down this side of the triangle, ultra reliable and low latency communication becomes more important than the speed. And the latency is accumulation of various delays from when a request is sent until a response is received. So if we look at the vehicle-to-vehicle communication, that's where latency becomes important. The latency in 5G, it's less than 1 millisecond. That means your vehicle would react to an event 200 times at least faster than human beings, because we do react. It'll take us 250 milliseconds to get the reflex of any event. So the cars would be much faster than that. And let's go to the other side of the triangle. As we go down, we will see some use cases here, like smart homes, smart buildings, and smart cities. And these applications would have more focus on density than speed and latency. So unlike past technologies that were extremely sensitive to the number of connected devices, 5G will be able to support many devices at the same time and reach densities of up to 100 devices per square meter. This is like 10 devices per square foot. Then Another important factor of 5G is the system spectral efficiency. The technology would be able to utilize the spectrum more efficiently than the current LTE technology. We're talking about 10 bits per second per hertz, and currently LTE is about 5 to 7. So from spectral efficiency perspective, we really improved on the use of a spectrum. And one other important feature is energy efficiency. 5G will be at least 90% better in efficiency than LTE technology. Let's cover some of the 5G RAN characteristics. Millimeter waves. I'm sure you've heard this term. And according to physics, the higher the frequency, the shorter the wavelength. So when we reach 30 gigahertz and higher, the wavelength is going to be measured in a millimeter. So that's where the millimeter waves concept come through here. And one of the features for the millimeter wave is that it packs lots of data. So you'll get lots of throughput through these waves, but these waves won't be able to travel further compared to LTE technology. They won't be able to penetrate the buildings. So they'll be densely populating the urban areas, and for these waves to be materialized, we use small cells. So in 5G, you will have small cells placed on like every 250 meters. You will find them on street furniture, on the side of the buildings. What's good about them, they're not big, and they have small antennas, and they'll be used in the millimeter wave technology. We still have the same technology when it comes to 5G because we use the same spectral sharing. It's called spectrum sharing feature. So the same frequencies will be accessed by 5G and 4G. So for low band or mid band, we still have the same range, but when it comes to the really high bands, then range would not be as important as the throughput. Another feature is the massive Mimo. The 5G technology will be supporting hundreds of antennas in an array. So it's like a matrix of little antennas that will improve the network capacity by at least 20 folds. And then another good feature of the RAN is the beamforming. Rather than just broadcasting in many directions at once, the beamforming technology or smart beamforming technology will actually track and follow the user as they move. So it will reduce interference, and it'll give better end user services here. So these are the 4 important 5G RAN characteristics. We have another core feature, which is called network slicing. This would slice the network end to end per the use case. So if you, as an operator, if you want to provide an IoT slice, you can have it end to end without any just dedicated slice for IoT business case, whether medical, utility, or connected cars. You can have also another slice as a consumer slice. You can slice it for postpaid subscribers, prepaid subscribers, and so on. So this is a new introduction of the network slicing into 5G. This did not exist in LTE. So this slide it will give you some kind of a view of what it looks like in 4G technology and 5G technology. So the one on the left is for 4G, and the one on the right is 5G. You can see a lot of small cells. So small cells will carry 80% of total traffic in the 5G world. Also, we're introducing some mobile edge computing because of the latency. If latency is extremely important, you don't want it to be far away in the cloud. So you just put it closer to the site. That's why it's called edge. It's closer to the actual site, that the access site here. Yeah, this slide is important. There are 3 functional units when it comes to RAN in 5G. It's divided into radio units and distributed units and centralized units. So the RAN, these are according to the OSI layers. You have the physical layer, which is the physical layer right here, and it's split into low physical and high physical layer. And then you have the network layer, and then you have the RRC, which is the TCP/IP layer. And depending on the split, you will realize different hardwares and different functions. I'm going to focus on just 2 splits here, option 7 and option 2. Option 7, you split the physical layer into, it's called also lo-fi, into 2 pieces of hardware, the radio unit, and then you have the DU unit, which combines the CU and DU together. So these will be, the DU and CU would be realized in the baseband unit, BBU. And the radio unit will be realized in the radio, remote radio head. And in here, this is the front hole. You feed the front hole is right here where you see the mouse. And the advantage of the split 7 is it's used for millimeter wave small cell deployments. It is used also for massive MIMO deployments. And the reason is the front haul, we will be able to have up to 100 gigabits per second. So you will have extremely high throughput, high bandwidth between the radio unit and the BBU. And this is it is one of the least expensive configuration. Then we talked about, then we go to the option 2, which it splits the higher layers of the OSI stack. Then you will divide it into 2 pieces of hardware. The radio unit will have also the distributed unit function within it. So you'll have the radio unit right here, and the BBU will be realizing the centralized function of the layer. This is, it's more expensive, and you will be utilizing what's called F1. This is a new interface that's introduced in 5G technology, which is a mid-haul. The mid-haul is the interface between the DU function and the CU function. You will have less bandwidth you'll have also only up to 10 gigabits per second right here. This is for typical sub-6 gigahertz macro cell application. They will use split option 2. You can also have double splits, split 7 and split 2. You will end up with 3 pieces of hardware. You will have the radio unit, which is the RRH, and then you have the BBU, which is it's the baseband unit, which is the distributed unit. And then you will have another piece of hardware, which is called centralized unit, and that's it can be realized as the mobile edge computing hardware. So some of the advantages of the split architecture, you will always have. You can move the new radio functions between central and distributed units. So you're not actually stuck in one place. That'll make it more scalable and cost effective. And you can also manage the load more efficiently. And the most important one is for virtualization. You can virtualize almost all the functions except the RF, which is the radio itself. It has to be, the radio has to be local, and everything else can be virtualized out on the cloud. So yeah, understanding this concept is extremely important for you to understand 5G and the Open RAN, the new Open RAN technology, because these interfaces are based on open interface standards. So you can actually have the radio head from one vendor, and you can get the baseband unit from another vendor, and the centralized unit from a third vendor, because they all use open interfaces, and you can mix and match. So this is an Open RAN illustration right here. We talked about the layers. So we have the radio unit layer right here. We have the distributed unit right here, and then we have the centralized unit. And if you look at this graph or a photo right here, the Pico radio unit is the RU functional split. Then it connects to the BBU, which can be the DU and CU functions together, or they can be also split. So this dotted line is a front haul, and then you have the back haul from the BBU or from the baseband unit all the way to the core network. At Baicells, we have end-to-end demo systems for 5G. 5G comes into 2 flavors: standalone, which is pure greenfield 5G technology. That you don't need any kind of legacy right here. And you can see we have the radio, 5G radio unit right here, and then the BBU, 5G BBU, and 5G core. So no legacy network whatsoever. And the hub is optional because you can connect more than one radio to the BBU. So you needed to aggregate the radios back to the BBU. Now this is the NSA, which is non-standalone. A lot of the tier 1 operators, they already have LTE networks that they invested billions of dollars, so they're not going to just throw it away. So it will take 5G radios also. As you can see here, this is a dual mode 4G and 5G radio. You can connect it to the BBU, which can be 5G or 4G, and I'll talk about this later on. We have cards that you can actually scale your BBU to handle both technologies. But the NSA here, we don't have the 5G core. It is the EPC that will handle both the LTE RAN and the new radio RAN at the same time. And you need this BBU to be able to handle both technologies, but the core can remain the same as LTE. And we have customers actually that have these systems on their labs to test and try things. All right, some of the our elements, 5G elements, we have the new generation core. That's a 5G core. It comes in 3 different flavors. The compact, that'll handle 5,000 active users and support 500 sites. Then we have the standard model that would double the compact. That'll get you 10,000 active users and 1,000 sites. And then we have the professional configuration, which will actually multiplies the standard by 10. So you'll get 100,000 users and 10,000 sites. This is the core. Now, the BBU, as you remember, 5G is about splits. You don't have one cell that handles all RAN. It's split. So one of the BBUs that we have, it's based on Intel x86, and it works as standalone, as I explained earlier. You can also configure it to work as to handle either the CU function or the DU function or combined. So it is configurable according to your needs and your configuration. Then we have another BBU that's based on cards. You can have, it'll take up to 8 cards, and they can be mix and match depending on your network between 4G and 5G architecture. So you can have this BBU to handle 4G traffic, the normal 4G traffic, or the new 5G traffic within one standard unit right here. Let's take you through some of the 5G radios that we currently have, and we're also working on developing, expecting them to be next year. We have the Gamma 632. Gamma is our trademark for 5G radios. These are indoor radios. So this guy right here is dual mode, so it will handle your existing LTE traffic, and it will introduce the 5G sub 6 gigahertz. 5G has, according to the specs, there is frequency range 1, which is FR1. This is anything below 6 gigahertz. That's why it's called sub 6 gigahertz. And then you have FR2, which is a millimeter wave. That's above 28, 30 gigahertz. You will go into what's called millimeter wave. So the antenna right here, it's 66R, so that's a built-in antenna. 6 transmitters, 6 receive, and the single channel is 250 milliwatt. And the new frequencies that we're introducing, N41 and N78. So N41, this is the educational broadband 5G, not 4G. Now, whenever you see N, it's 5G, and N78 is the C band, which goes from 3300 all the way to 3800, which includes the CBRS 3.55 all the way to 3.7 megahertz. So you can have the LTE and 5G working on this radio right here. Another radio that we're working on is the Gamma 833. Now it handles millimeter wave also. So it's dual mode LTE and 5G technology, and the 5G, as I explained, it's split into sub 6 gigahertz and millimeter wave. So looking at the bands right here, N261 and N269, these are the millimeter wave. These are these where you get the 10 gigabits of speeds right here on the millimeter waves. And the antennas design is we're going into Mimo, the massive Mimo now, 8T8R. So you can actually you can split it into two sectors with 4x4 each. And single channel output is 200 milliwatts. Some of the outdoor radios that we have for 5G, it's 844, Gamma 844. This will handle, it's all dual mode, so LTE and the sub 6 gigahertz of 5G. The radios, with increasing the number of transmitters and receivers to go into massive MIMO, so you'll see more antennas on these outdoor radios. Now the difference between 5G and 4G, in LTE, the maximum bandwidth that you can work with is 20. According to the specs is 5, 10, 15, and 20. But with 5G, you take it to 100, and you even take it to all the way up to 800 megahertz of bandwidth when we talk about millimeter wave. That's how you actually pack more data. You open up the bandwidth, and 5G specs is doing this. So we go to the 8443. This is, we're getting, it's a little bit more powerful transmitter than the previous one, and it covers the N41 and N78 and the millimeter wave as well, N261 and 269. We go to 884 series. We're increasing the antennas, so we're going into massive MIMO. You can have up to 16 by 16 right here, and in more powerful transmitters, 10 watts, 40 watts, and 8 watts. In the spectrum here, it is going to be the sub 6 gigahertz plus the millimeter wave frequencies. This is I'll take you through some deep dive here into one of the radios that we're doing, which is Gamma 846. That's an AAU, which is active antenna inside. So this box it includes the antenna, so you don't need to incur any expenses of external antennas. This product we're offering for RDOF. It is meeting and exceeding the RDOF requirements. Let's look at it closely here. It supports LTE and the new radio technology, which is 5G. Of course, it's TDD, and the antenna is 8 transmit, 8 receive. So that's why we call it 8x5. So this is called 8x5 like we have 8 ports and 5 watt per path. So 8 by 5. The frequencies we're doing in 41, that's the 5G EBS, and the classical CBRS LTE band right here. Bandwidth can get to 100 megahertz, and it is according to the 3GPP standard. So all of our products are 3GPP compliance. Carrier aggregation, this is important here. You can, if you want to use CBRS band B48, you can aggregate up to 4 carriers. That'll take you to, each carrier is 20 megahertz. That'll give you a bandwidth of 80 megahertz. And then 1 carrier in the 5G. The N41 carrier bandwidth is already 100. So, you don't need to aggregate anything on 5G. It is pretty compact. The volume is less than 8 liters. Weight is 8 kilograms. So this is like 17 pounds. Power consumption 200. And if you remember, because this is an RRU now, it's 5G. No more consolidation of RRU and BU in one standalone cell. Now to connect to the BBU, it goes through front hole, which is CPRI connection or eCPRI. So eCPRI is for 5G and CPRI is for the LTE. We have the data interface. You can see we have two 25 gigabit of Ethernet SFP+. This is the fiber connection. This is the eCPRI. And AAU is supported, which means the antenna is built in and the antenna gate is 10 dBi. So it's a built-in. And we support dual modes. We support beamforming. Beamforming, as I explained earlier on, it's not going to be just broadcasting all over the place. It will just track you and lock the user. It'll give the end users great user experience right here. Supports DU. That's if you remember the split, the RU, DU, and CU. So it supports the splits, and the synchronization is done through the 1588 standards. Okay, so this is just one of the radios, 5G dual mode 5G LTE radio specifications that we already have, and we have it. We're testing it right now on the field. There's some other down the road, second half of next year and earlier 2022, we will have more antennas support. So we'll go through 16 by 16 and then here the massive 64 by 64. So this is the massive Mimo concept that I explained earlier. So that will greatly improve capacity. And still, we will be handling the 5G bands right here. So the difference as we go on is just we're having more support of more antennas, and with that you can you can actually divide your cells into different sectors according to your needs right here. All right, we have what's called acceleration cards. If you remember, one of the BBU that will take cards, 5G cards and 5G cards. So this card right here can support 6 front hole fiber ECPs, eCPRIs right here. There's just one card. And as you can increase the cards in the BBU shelf right here. Another unit that we're introducing, which is called extended unit, which is a front hub. This will connect. It has many optical interfaces. It will connect the radio units, all these optical connections. It will connect the radio units to the BBUs, and for scaling, it connects to like piggy bank into another extended unit to have more radios connected to BBUs. So you can scale it the way you see fit for your network. Okay, these are some roadmaps that we're following, features and hardware and software releases. You don't need to go through the details. This is just to show how simple it is to actually expand the network. One BBU can support up to 4 cells, and each cell can support up to 32 radio units. You can see here the Gamma 632 indoor radio. You can connect them like an access point, Wi-Fi distribution right here. They can connect to the extended unit, and the extended unit, this is front hole right here, will take it to the 5G BBU, and 5G the BBU would backhaul it to the 5G core, and you can actually scale it, as your business case needs. So this is for indoor 5G indoor installation. Also, when we talk about outdoor, it is part of a heterogeneous network. You can have the AAU on a tower and front haul to an extended unit and a BBU, which will backhaul the traffic into a cloud-based or local-based EPC 5G core right here. And you can also, you have indoor radios, outdoor radios, they all work together as one network. Now, this is a quick slide for RDOF. If you guys are familiar with RDOF, there are requirements. The above baseline is 100 on a downlink and 20 megabits per second on an uplink, and then you have the gigabit requirements. We have these two products that have been developed and tested actually now for the RDOF requirements. The RAN part, if you remember again, this is the split. This is the RRU, which is 8 by 5 watts, and it is 5G ready, and it's dual mode, so it works on band 48, the CBRS, and on the new frequencies, 5G frequencies, 41 and 78. Then you front haul it through Norma 1000, which is the BBU, and this can handle up to 3 cells, and each cell will take care of 256 users. And it is 4x4 Mimo, and it has carrier aggregation on a downlink and an uplink, and it's 256 QAM ready. So in order to achieve these speeds, then we have actually we just certified this last week, which is the Catch 15. This is perfect companion to the distributed RAN unit right here. I'll take it will aggregate 4 carriers on a downlink and 2 carriers on an uplink, and it has lots of new features, very high gain, 18 dBi on an antenna, and this can be used as an outdoor CPE for the RDOF technology. Then we have we have what's called Lte Turbo, which this is for the gigabits technology. This will aggregate the Wi-Fi 6. Now we're working on Wi-Fi 6 with the CBRS LTE channel to give you the gigabits on upload and download also. And we have a CPE companion, which is Lte Turbo, that will aggregate, that will be capable it will be able to aggregate the Wi-Fi 6 and LTE CBRS together to get you into the gigabit of speed and throughputs. And depending on that configuration in your engineering, we can dimension how many do you need in order to achieve the speeds, these speeds at the edge of a cell. Now, to protect your investment, I mean, once you have the radio, the 5G radio capable, this is future-proof for you. And if you remember the Norma 1000, this is the BBU. If you want to take it to full 5G, because this is the 4G support, then you need to get a 5G BBU. So with the Norma 1000, you will handle all the LTE traffic, and it's only software upgrade. And with a 5G BBU hardware, that will take care of your 5G traffic. So all you need to do, if you opt for this solution right now, to be able to handle 5G traffic, you need to have 5G BBU. So you don't need to climb on towers and change radios, because radios are for 5G ready. So, but the BBU needs to be changed. And the EPC server, which is the core network, is only a software upgrade, whether you have it locally or on the cloud. Another way of protecting your investment, if you remember, we have the x86 server where you have where it takes cards. So you can have the radio units that we talked about connected through x86 4G server. And if you want to have it 5G ready, the BBU that is, all you need to do is just add the 5G card. And that's it. This 5G card will be able to handle the 5G traffic for you all the way up to the core network. So you're not going to be changing any hardware right here. All you need to do is just pop in another 5G card, connect it to your network, and just backhaul it to the EPCs, 5G EPCs.